Earth is a tiny blue dot floating in an immense cosmic ocean. It holds everyone you have ever known, every human who ever lived, and every story ever told. But when we zoom out past our atmosphere, we immediately crash into the staggering realities of scale. Our closest celestial neighbor is the Moon, sitting about 384,000 kilometers away. If you could somehow drive a car at a constant highway speed of 100 kilometers per hour, it would take you over 160 days straight just to reach it. Even stepping up to the speed of a commercial jet flying at 900 kilometers per hour, the math quickly becomes daunting. Crossing the 150 million kilometer gap to the Sun would take 19 years. Reaching Mars, even at its closest approach, would take upwards of 50 years. By the time we reach the edge of our solar neighborhood, human speeds are entirely useless. Neptune is 4.5 billion kilometers from Earth. To measure expanses like this, we have to use the speed of light, which still takes 4 hours and 15 minutes to make the trip. The familiar planets of our solar system are merely a prologue. To grasp the true scale of the universe, we have to measure it by the disappearing boundaries of our own physical influence. Launched in 1977, the Voyager 1 space probe represents the absolute limit of our physical reach. It has been traveling for over 4 decades and is now more than 22 billion kilometers away from Earth. In 1990, astronomer Carl Sagan suggested turning the probe's camera back toward Earth. From 6 billion kilometers out, it captured a faint speck of light, offering a sobering perspective of our home from the outer dark. This 3D scale map visualizes the Oort cloud, a vast sphere of icy objects marking the theoretical edge of our solar system. The distances here are so immense that standard astronomical units lose their practicality. We switch to measuring in light years, with this cloud extending 1.9 light years from the Sun. Even with Voyager 1 traveling 17 kilometers per second, crossing the void to our nearest star system, Alpha Centauri, located 4.4 light-years away, would take over 70,000 years. The enormous time required to cross even the smallest interstellar gaps means that, on a cosmic scale, our physical reach essentially rounds down to zero. Beyond those immediate stars, we enter the grand architecture of our home galaxy. The Milky Way spans 100,000 light-years in diameter and contains hundreds of billions of stars. Since we cannot travel there physically, our furthest influence relies on our fastest, non-physical emissions, the electromagnetic radiation from our early radio and television broadcasts rippling outward into the cosmos. This vector map of the Milky Way puts that signal reach into perspective. That microscopic sphere you see highlighted is the human radio bubble. It extends just 100 light-years into a galaxy that is 100,000 light-years wide. Any civilizations residing in the vast majority of our own galaxy would be completely oblivious to us. Our entire recorded history is a whisper that simply hasn't reached them yet. Stepping out into intergalactic space, the Milky Way shrinks entirely. We are part of a small cosmic neighborhood known as the Local Group, a cluster of more than 50 galaxies spread across roughly 10 million light-years. But even the Local Group is swallowed by the colossal Virgo supercluster, a titanic structure containing thousands of galaxies that spans 110 million light-years in diameter. This branching web visualization displays an even larger scale, the Laniakea supercluster. It contains the mass of 100 million billion suns, and as you can see, the entire Virgo supercluster is reduced to a single dot within it. Deep epicenter of Laniakea sits a mysterious region of space known as the Great Attractor, exerting a massive gravitational pull that binds this entire cosmic web of galaxies together. In this context, our home galaxy is merely a microscopic component locked within an incomprehensibly immense gravitational system. Pushing to the absolute boundaries of our exploration, we hit the limits of human vision, the observable universe, an astronomical expanse stretching roughly 93 billion light-years across. This creates a fascinating cosmological paradox. Scientists know the universe is only 13.8 billion years old. So how can we possibly observe a structure that is 93 billion light-years wide? The answer is cosmic expansion. Space itself has been stretching since the Big Bang, constantly increasing the distance between celestial bodies. Because of this, distant regions are moving away from us faster than light, crossing a boundary forever out of our view. The true size of the universe is unknown and potentially infinite. Entire galaxies will retreat endlessly into the dark, remaining unseen forever, leaving us with the humbling realization that humanity is an infinitesimally small but profoundly precious observer of this cosmic ocean.